Please share your social security number. One. Yes. All right.
First, social security.
This is following me. Do you see my screen? You do not. See if I can fix that.
Someone see. That gets to see it's like 190 messages.
In theory, the technology works.
Infra.
No.
Some stuff only checks for last one. This is infra.
This? I don't know. This probably broke Twitch. So we'll find out in a moment. Sweet. So I don't have a lot of slides today. I was building a different kind of slide deck. So no cool Twitch is broken. No cool grade data, nothing like that. Beautiful. So today's November 13th here at CSE466, and we are wrapping up sandboxing. It's been a strange couple of weeks. I think you all would agree. We are now at, that's fine. As long as it doesn't spin around and show you all smiling face, we're in good shape. We have been going through 1 week modules, which some of you have adapted to, others haven't. One of the surprise things that we didn't plan for scheduling wise is it turns out there's a lot of holidays that line up in here. And I think we're going to see the same thing. I think it was MicroArch that lines up with Thanksgiving break. So that's fun and exciting. We are finishing up sandboxing here. From what I saw on the Discord, most people have gone through the CH root challenges and they are stuck on the sandboxing stuff. Is that roughly accurate? Or maybe they solve the sandboxing stuff, but they don't quite get what's going on there. That's fair. We are launching kernel tomorrow. We'll see how that goes. So in order to talk about namespace, what namespacing is, we have to first think about how processes work, right? And we've kind of alluded to this a little bit throughout the course. All the way back when we were writing shellcode, which some people meme that this module is basically shellcoding redone, right? Shellcoding V2. Some of the challenges have asked you to write shellcode. How do you interact with the file system? How does a process interact with the file system? What do you do? Cat flag. Okay, that's one way that I could interact with the file system. But how does cat interact with the file system?
It's a great question.
Nobody knows. It's a mystery. We'll have to ask that one on the exam, right? So somebody said a syscall, right? So is it possible for a process to interact with the file system if it doesn't use a syscall? Can I do that? The short answer is no, right? What if I want to interact with the network or communicate? I want to connect to a socket. How do I get sockets? How do I send data over the network? Okay, I talk to the kernel and I do that via a syscall. When I do PSAUX, what does that do? It's a bit of a trick question. You'd think the answer is syscall.
/prog.
There probably is, right? There probably is a syscall here. But another way of looking at it is it's going to interact with, let's actually trace it and find out. Does it interact with proc? It does not. Does it?
Look, scroll up.
Scroll up.
A little more. A little more. So, right there. Open at
Where am I?
Like 5 lines from the top.
5 lines from the top? Okay, I'm interacting with /proc up there for something. Now what am I doing? I'm calling stat on some processes. What is proc?
All the running processes. It's a directory.
Okay, it is a directory, right? We have proc chilling right here. What's unique about proc?
It's not like it's weird. It's fake.
It's weird. It's fake, right? That's true. If I take a look at proc, we have dynamic files and directories, right? They're all of size 0. Proc is a pseudo file system. What happens when we read and write to the pseudo file system? What are we communicating with? The kernel. So if I want to find out, like, what is the state of the system, what's going on, what other processes are running, my process still relies on the kernel. What if I want to, like, create a pipe, right? And I want to, like, send something from one process to another. Or I want to create shared memory. Can a process just do that? No, it relies on the kernel. And so to do anything other than like some basic addition computation kind of things, like working with bytes, processes rely on the kernel. Now, this is done for a good reason, right? Because the kernel takes care of all of the details that you don't want to deal with and I don't want to deal with, right? If I'm running my Linux environment here, and I type ls, I'm allowed to look at this file system. This file system is probably ext4. Let's find out. Should be. Nope, it's an overlay FS. Now, if I have to think about whether I want to do this. If I'm on my Mac and I ls /root, I can do that. Is this an ext4 system? No, it's a different file system, right? If I'm on here and I ls temp, I can do that. But if we were to mount grep temp, we would see that temp is a tempfs file system. Does ls have to worry about this? Do I have to know how to interact with an ext4 file system? No. Do I have to know how to interact with the tempfs file system? No. The kernel is the thing that does that. Same thing if I want to mount NTFS, which is Windows file system. If you install the drivers, which is like a kernel module, so that the kernel knows how to deal with NTFS, you can ls on a Windows file system. The kernel takes care of all of that so that you don't have to worry about it as a user land process. Okay? And this is a good thing. The kernel's job is to translate our request to whatever the hardware is or the reality of these outside resources. So processes implicitly have to trust everything that the kernel says, right? Is there any way that a process could know if the kernel's telling the truth? No, the process can't verify it, right? The kernel has trapped us, so the process is we just have to trust whatever it is. So my question is, what if the kernel lied to the process about the state of the world? Can we do that? Probably, right? You used to not be able to do this, but you can now. This is the kind of core idea of what a namespace is. So if we take a quick look at, I'm using proc cell, but inside of proc, there is this ns directory, which is shorthand for namespace. This is showing me all of the namespaces that my current process, which is actually ls here, resides in. I don't have to know what these are. They're just going to have some number that represents the namespace. And by default, we're all functioning in the same namespace, and everything is true and everything is real. Okay? But we can lie. So a namespace is a lens into, like a custom view into a type of resource or a particular aspect of the outside world that we rely on for. There are namespaces for our host name. Seems silly, but there is. There's a namespace for what kids are available. There's namespaces for what is the file system or what is mounted on the file system. There's a namespace for your network. There's a namespace for IPC, which is inter-process communication. This is the shared memory, creating pipes, any of those type of shared communication between processes. There is a namespace that dictates what resources are visible or not. There is a namespace for time. So we could just say that it's a different time if we want it for a particular process. And there's a namespace for users. There's actually a couple more I think are not on this slide. And so we can lie about what user we even are, or create our own user hierarchy. Now, namespaces are insanely complicated. If we look at man 7 of namespaces, 7 is for like conceptual things. We have a giant man page that explains how namespaces work. There's two ways that you can like create a namespace. You can create a namespace via the syscall unshare, and you can create a namespace via clone. Any of you interacted with clone at all? Probably have, you just didn't know it. Clone is the low-level syscall that happens when you create a new process, when you fork. Clone just takes 1,000 arguments, and there's like 5 versions of clone. There's clone, clone 2, and clone 3. And each one of them takes a more complicated configuration for what you want that child process to do. So there's 2 ways that we can create a namespace again. We can use this unshare syscall, or we can define what namespaces we want to interact with and we fork off and create a child. Okay. Now I conveniently for myself is these are crazy. And you do not remember these. Listed the command here that I need to spin off and like spawn a child process in a new namespace. So this unshare command here, which is unshare -u -p -m -fork -mount proc bash. -u is going to put us in a new host name. It's UTS, but a new host name namespace, which means that we can lie inside this process about the host name. We can change it and it doesn't impact the host system. -p is for the PID namespace, which is I want there to be a whole new set of PIDs. -m is for the mount namespace. I want there to be a new concept of a file system, right, to this process. -fork is required for me to do the PID. That's kind of an implementation detail. And then -mount proc says, after we are in this environment, I want to create a new /proc. And then the command that I'm running is bash. And it failed. Anyone know why it failed? Sudo! Right? Just like chroot, which you saw, you can't run these commands unless you are root. Hopefully I am in practice mode. Perfect. Okay. This is why we're not going to have cool. Depending on what challenge you're in, fun, dojo, infrastructure, detail, you are sometimes inside of a VM silently and sometimes you are not. This was a problem in me creating some of these demos. And turns out this runs in the bare metal if you're in a different challenge, but not in the one I happen to be in now, because this one is not silently in a VM. So I ran VM Connect so that we don't have to worry about dojo infrastructure details. I run this sudo unshare -u -p -m -fork, blah, 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 blah. What should be different? I said, well, we're in the U, so my host name could be different. Is my host name different? No. I can set my host name, though. Again, host name. This is a lie. Okay. And then I could run host name again. My host name for this process is this is a lie. Now, if I go outside of here, and we'll still connect to the VM in this bottom box, so it's not the VM that's making a difference. Oh, we see that this process thinks its host name is this is a lie. Now, the process that is not inside the namespace has the correct host name. The other thing I said is we use -p, we're in a different PID namespace. How would I look at the PIDs that are visible? What would I run? Okay, we could ls-proc. We could also psaux. There are 2 PIDs in this system. That's what we got. And if I'm down here inside the VM outside of that namespace and we psaux, we see that there's quite a few more, right? Oh, because when we entered the PID namespace and created our new proc, this new proc is going to lie and say, hey, this is all that's there. Now, one way that you can know that you're in a PID namespace is by looking at PID 1. This is roughly true. One can correct this. What should PID 1 be? Yeah, PID 1 should be, you're still inside a Docker container here, but it should be systemd or some init system, right? It would be very unusual for a host system to have PID 1 be bash, because PID 1 is responsible for reaping all of the children. It's the first process that ever comes into existence. And so if you PSAUX and you get something like this, odds are you're in a container, you're in a PID namespace. Not necessarily a container, we haven't gotten there yet. We were definitely in a PID namespace. The third kind of namespace I said that we're setting here is the mount namespace with -m. Well, the file system looks the same, right? If I ls bin, the VM is going to take its sweet time, but these look the same, right? So what's different? Well, as the name kind of implies, it's when we mount things. So if I go into temp here, go into temp down here, I am already root. That's kind of interesting. I will make dir my mount. And if we look here, I do see my mount on both of these. So I haven't lied about the file system yet. In order to take advantage of the mount namespace, I have to actually mount something. Let's see if I can remember how to do this. I will mount t temp on temp my mount. Unknown file system. Oh, it should be tempfs. Bam. So now if I touch temp my mount A, it doesn't exist here, but it does exist inside of my mount namespace. And so the mount namespace allows us to mount things that are only visible to the process inside of the namespace. And on the host system, I don't see it at all. And you can do the inverse. This is where that pivot route that Jan did that got crazy. I've never successfully ran pivot route, so I'm not going to go down that road. But it takes advantage of this same mechanism where you enter the mount namespace and then you remount basically what is at root, at which point you've defined a whole new file system. Any questions about what's going on here? There's a couple of questions that you may have. So I'm in the PID namespace. If I PSAUX here, we said bash was PID 1, but when I was on the host namespace, we said PID 1 was this and that. Can the host namespace see this bash? Somebody says yes. Why?
Because I think it would be like a be able to see it back.
I'm sorry, I didn't catch that.
I think like the otherwise like a child of the host, so it should be somehow it back.
Okay, so it's a child of us, right? I spawned it from this team up session, and so you would think, yeah, the parent process or the parent environment should be able to see the child one, and that would be correct. Well, what PID is it? I'm going to do PSAUX dash or PSAUX F. This gives us this cool hierarchical tree. And what we see here is that on the host system, this is my bash, it's 435. This is my SSH connection coming in. This was the bash session that I had. There's my unshare command. Here is the bash that is running inside of its own namespace. Namespaces are hierarchical. And what I mean when I say that is whoever spawns the child namespace can see into it, but you can't see up from it. Now, how can I see these namespaces, or how else can I interact with these? Well, I already said that there's /proc pid ns, right? Is that going to look different? Granted, I'm looking at different processes, but are any of these different? We just treat the numbers as magic identifying numbers. And the answer is yes. As you would expect, the namespaces that I specified on unshare have a different number to them, right? I have a different mount, I have a different PID, and I should have a different user and, or not user, UTS. All right, that's kind of cool. Now, it's not just unshare and clone that are interesting. There's another, oh, what am I looking for? Let's go here. And this should, that's, hey, there's this other thing going on called setNS. setNS is a system call that allows the calling process to join an existing namespace. But I need to reference a file that refers to this namespace. And this namespace is like this abstract thing, right? It's a window into some resources. Now, one of the Linux philosophies is everything is a file, right? And so this proc we said is a pseudo file system, right? Proc pid ns is a file, but what does it refer to? Like, can I cat it? Does that make sense? No. Can I read it? No, not really. The only thing that you can really do to this namespace file is call setNS, right? I can ls it to like identify it, but I can call setNS to join the namespace. So let's look at the man page for setNS. Do I not get, isn't there? Oh, rip. Okay. We can do this the long way. We have to make a do.c. It always boils down to do.c, doesn't it? So let's follow the rules of the man page. I swear there's a bash command that's like setNS and you just do it. We can do it this way. You'll have to do something similar anyways. Hint, hint, nudge, nudge. Okay. So I want to call this setNS thing on some namespace file descriptor, and then I need to set this NS type. And if we look at NS type, it says the argument specifies what type of namespace you're interacting with. I think something that might be interesting to do in our current scenario here would be I want to, from the host system, join the mount namespace of this child, and then write to that A file. Because I can't get to it from the host system, can I? It's in a different mount namespace. So how would I do that? You should find that user pid. This I need this right here to be the second argument of setNS. And then I need the NSFD to open that PID. Which PID was it? This guy right here, 435. So we'll open proc 435 NS MNT. We'll open it, read write. And then because the compiler is super picky, we will include whatever it's. Okay. So my claim is after this, we are in the mount namespace, but only for this process and only after this set ns has been called. So what do I want to do after that? Well, let's open that temp file guy. What did I call it? Where did I put it? My mount A. Open that. Read write, because why not? And we will write to this FD, yo. To include whatever write wants. Okay, let's see if this semicolon, you know, semicolons are a thing of the past. In FD equals. There we go. Okay, did it work? I don't know. Let's find out. Cat, my mount A. It did not work. Any ideas why that didn't work? We said it earlier. Yes. In order to interact with these namespaces, I need to be root. We can't just have random users YOLOing into random containers all over the place. And these namespaces are the underlying primitives that make containers and these type of things work, right? So I do need to be root. Now, this is a dojoism. You can't sudo, or you can't set UID. I can sudo this. Sudo a.out. All right. We're still a liar. Uh-oh. All right. Let's bring out the big guns. Okay, what happened? So some people recently discovered strace from this module, which I think is kind of amazing.
Here, 7. You have bad file scripted file.
No such
I can't read.
Open app failed.
You're not in the PM though.
Classic dojo failures.
Would it have been better to do Kata VM than to start with it?
Would this be better to do?
Like to start with a Kata challenge.
So it turns out Kata has its own problems, which is why the other half of my demos that I'm not doing don't work. Because there is actually no good solution that can do everything that I want to do. Okay, so my issue, as someone was nice to point out, that would have taken me a long time, is I'm not inside the VM. I still need to be sudo though, so that's true. I sudo a.out. Okay, that took a little bit longer. If we go over here, does it work? Oh, we're still bricked. Okay, things are getting serious. What did I fail at? Open at worked.
Operation updated. Wait, run the asterisk with sudo as well.
Bad file descriptor on open at temp my mount A.
Run the asterisk with sudo.
Permission
Oh, you're right.
on proc 435 ns
Oh,
mount.
that'll be great.
That exists, right? 435. That exists.
Please work the root.
Why are you a liar? Is it mad because of the? It could be mad because of the right. I don't remember that. GCC. No. GCC, do not see. There we go. So did everyone catch what the issue was there?
You were trying to.
I was trying to open the /proc pid NS mount. Where is it? Open.
Down.
Some Nixon sanity. This. I was trying to do this. It's just called right here. This it ended up being open app, but I will open. Right here, I was trying to open it, read write. And the kernel just says, hey, man, this isn't a real file. You can't write to it. Don't open it that way. You can't open it that way. This isn't real. And you'll find that that is the case for many of the files in the pseudo file system when you're interacting with the kernel. There are files that you may want to open read-only. There are files you may want to open write-only. There are files that you can open read-write. In this case, in order to call setNS, I don't need to actually write to it. I just need to have a read handle to that file descriptor. And we see that that did work with strace, and hopefully, oh, we see it there. I didn't write a new line, but we get yo root. Okay. So we are able to interact with that via setNS. Now, this is a reasonably sane setup of namespaces, right? I created my proc. I created a new proc in here. What do you think would happen if I didn't create a new proc and somehow I kept the old proc? See if that works. Okay. Am I in a child process? Yeah. Okay. So I am inside my UTS namespace. I am inside my PID namespace. I am inside my mount namespace. Before it's off and running bash, I should be safely in this container, right? Oh, I am. I am safely in this container. But what did I leak out here inadvertently in my design of how I'm running this this containerized process? Okay, so cool. Can I got so what does this help me with? I'm still in this environment, right?
What if you did? Are you allowed to do setNS with one of those? Or is that
That's a question. Can I run setNS on one of these? Well, what are these?
those are file descriptors of the host? It's like one above them.
Right, these are file descriptors from the proc of the host system. And so if I were to wait, what process do you like? A good process that you can rely on is proc1 should exist, right? And we could cat, for instance, proc1 command line to see what it is. And we see in this case, but if I were to PS, what do I get? Well, I get everything that's there. What good is this PID namespace? What good is it doing for me? Finds out about the namespace. Right. So what I'm trying to get at here, which you hit, right, is I'm in my own PID namespace, but commands like PS, they just rely on proc, and we just carried proc on through the host system. So if this is going to work. So let's go on the host system and let's make sudo make dir Rob's secret folder. We look here. Oh, you get to see it? That's fine. Mount point does not exist. Tob. They called him Tob. Okay. So inside my container, I can't see this resource that is on the host system. Now, what the astute student pointed out was, well, can you still call setNS? The answer is, yeah, you probably can. Right? If I change this here, and I change this here, what did I make it? Rob, secret folder. Nope. And instead of write, We're going to read it into some buff. And we'll write it out. We're going to get some garbage bytes, but I don't care. Okay. Let's build our do.c. And we're able to take advantage of that. So namespacing is super cool, but if you manage to leak any resource out, it gets very tricky on allowing somebody to escape. Now, another thing that you'll notice is when I was on the host system here, I was over here doing sudo a.out. I needed to be root. Did I need to run sudo up here? No. Why? Am I root though? I'm root in the namespace, right? We are in a user namespace. We're just like, yeah, man, I'm root. I'm root in the context of this user namespace. And to the kernel, that's good enough for me. It's one of the reasons why if you have used Docker at all, or talked to people about Docker, they'll make the comment that adding a user to the Docker group, which is like super common, right? You install the Docker service, and then you're like, I don't want to run sudo docker every time I want to run a command. This is annoying. And so you do usermod ag docker onto your home user. Right? No, everybody does this, right? It's not even mean. The statement is that's equivalent to giving that user free root, right? Because Docker leverages these namespace technologies, right? That's how you get different file systems when you drop into a container and you're a different user. It's a different user namespace with a different mount namespace with a different network namespace. Okay. But can I mount things using Docker? If I'm an unprivileged user, can I mount some privileged resource into my container that's only accessible by root? The answer is yes. Can I be root inside the container? Yes. Does that pass the check so that I can just cat the file? Yes. And so giving an arbitrary user the ability to play around with Docker and namespaces and these type of things, which is kind of the de facto standard, is free privilege escalation for that user. Somebody says too many procs in the kitchen and meow. I appreciate that. We will share it with the class. Does anyone have any questions about what they've seen here so far? Is it helpful? Yes.
You only need to read only time to that read or that right of right?
I apologize. Can you speak up?
You only need that read only tag in order to do that read or writes later on in the C in the do.c.
Okay. So the question was about the read only open access, which was a great thing here. So when I originally had this open right here, when I'm trying to open the file descriptor or the file that refers to the namespace resource, the kernel will not allow me to open it up with write access because it just doesn't make sense. And so when I did this with read write here, and we S-trace it, what we see is the open at here fails with a not permitted there. So we're not allowed to open this file path. And if we were to take a look and say, hey, well, all right, well, tell me what is that file? What was that? proc1 ms. If we were to like file type this, it's going to be, I'm curious now. Let's do that. Why make a claim when you can verify it yourself? It's clearly a symbolic link to whatever this is, right? And we have no bearing on what this is, right? I can't ls whatever mount colon whatever it is. And you'll find that this this pattern of like resources being represented by a file descriptor or a handle is very common in multiple operating systems. Now, Linux likes to expose these resources via the file system. Windows is a little bit more opaque, where the same concept exists. Where like if you want a handle to a resource, they call them handles. It's still just a generic number that you pass back to the kernel and say, give me access to this. This idea of a file descriptor referring to a resource here, in this case a namespace, exists in other elements. You can open up, for instance, files that represent shared memory. You can't get to the path that is shared memory, but I can hold a file descriptor that refers to shared memory to the kernel.
You stat it. Where'd you stat it?
What do you want to do?
Stat it.
You want to stat it? I don't know. Did we learn something?
Oh wait, what's the one that follows the?
You should know this, not me. Eh? You didn't you guys just do this?
Isn't stat?
I thought stat was the one that.
Stat just L is normal stat, right?
Dash capital L. Right? I just read man pages. I accept that I can't remember all this stuff, guys. Right?
You learn empty file.
It is an empty file. That's super useful to us, right? You at some point, you just have to like accept that this is just a magic handle into the mind of the kernel, and we just trust the kernel. And this is very much the case. You'll find that same thing if you start digging a bit deeper into, for instance, shared memory. Right? And so we were able to play around a lot with namespaces, just using the simple idea of unshare and clone. Now, what Jan, in his glorious live stream, all right, it's one of the live streams. He uses something called pivot root, and pivot root is the bane of my existence because it is very good at destroying your computer. While I was working on the demo, I managed to do it to one of my home lab computers earlier today, which is why we're not going to do it live now. All right. But Jan somehow did manage to pull it off and make it work live on stream, and I commend him for that. So we have the idea of creating this mount namespace, and I could remount root, right? And if you've gone through the first half of sandboxing, you probably would be like, okay, I set up all these namespaces, and then what would you do? Okay, pretend pivot root doesn't exist. What do the earlier challenges do? True root, right? CH root, perfectly good thing. CH root's been around forever. CH root goes all the way back to BSD jails, which was the first idea of a container. And so I could make this mount namespace. I could mount whatever I want, and I'll just CH root to what I want, right? Wherever I want to be the root. And then what's the other thing I have to do if I use CH root? I have to CH dir into the root. If I don't do that, bad stuff has happened. Right? And you could do that. I could set up all this mount, do this unshare, drop into something, right? If I have here, if I wanted my, what do I want? What did I make in temp? My mount. I did CH root my mount. I could CH root temp my mount. Well, I can't because I don't have bash, and this becomes a whole thing. I had a beautiful demo that solved this with BusyBox, but it doesn't work.
But it wouldn't work because your root seed culture.
Okay, so someone pointed out that if I were to do that and drop into there, I'm still root, so I could call CH root, which Michael had probably the best analogy ever on re-CH rooting, right? So when you CH root, you're defining what root is. You're kind of defining where the wall is. Am I on stream? Yes, this is my wall, right? And so I'm outside the wall, and then you CD in the wall. What happens if you are root and you call CH root again? You move the wall. And so, instead of trying to run yourself and escape the wall, you just move the wall through you, right? And then you're already on the other side of it. Now, if I were able to CH root here in the temp mount, because I'm root in the context of that container, I could just CH root again, move the wall in front of me, and then just happily back my way back out of the directory, right? But I could CH root and then make a user, right? Let's see if I remember how to do that. By user add, somebody is named Bobo, right?
That's great.
All right. I'm now Bobo. Right? Does Bobo exist on the home system, the host system? Why or why not? I just added a user. Yes or no? Do you think Bobo exists? If I were to go down here and look, is there a Bobo? There is not. Why?
You set the users.
I'm in a different user namespace, right? And so I could do this, right? I could ch root and then change myself into Bobo, and then Bobo can't move the wall. And that doesn't change anything on the host system because I'm in a different user namespace. Pivot root is just the fancy version of ch root. It effectively does the same thing, except there's a whole lot of crazy mounting stuff going on, and it will blow away your file system and you have to reboot if you do it wrong. And so I don't think pivot root is super interesting in that regard if you just accept that it's like the modern version of ch root. But if you want to make it work or see it work, look at Jan's lecture or look at the later challenges here. Maybe. The later challenges that do namespacing in sandboxing. These all, as the name kind of implies, are attempts by Jan to create a container using these primitives, using these namespaces, and then using pivot root to change things out from under you, right? But just like with ch root, you have to cd into it. With pivot root, there is, which the man page helpfully tells us, there's a new root and an old root, and we actually mount old root as part of new root, and you have to remove that after you pivot. And if you fail to do that, then you would have a path from new root / old root that goes to the host file system. You have created a new file system inside your container that has the host file system mounted inside of it, which sounds crazy. Play around with the challenges and you'll see what I'm talking about. So, namespacing is just the kernel lying to you, and it can lie to you about all of these things. One of the things that I wanted to demo, but for whatever reason cannot, is the network namespace. The network namespace works a little bit different. The network namespace is configured via, let me show you the commands, via the IP command. All right. So there still is a proc pid ns file descriptor that represents your network namespace. But when you create a network namespace, this controls not what you can see, but it controls what network devices exist, right? Because that's something the kernel controls, and the kernel informs you. What network card is plugged in? That is what the network namespace controls. It controls the routing table. So what device or port should I route packets through? That is something that the kernel controls, right? And so that's something the kernel can lie about. Or the firewall rules. If you did 365, what was the
Intercepting communications.
Intercepting communications, right? That entire challenge series is built using the primitive of a network namespace. It's just done in Python. It's a Python wrapper. And remember, all higher level language abstractions, at the end of the day, you're interacting with the kernel. You're calling the same syscalls that we've seen here in C. They're just more layers of indirection between your high level code and calling that syscall. And so when you create a new network namespace, you're saying, all right, kernel, you know nothing. There are no devices. Okay? And that's what we're doing up here with IP netns add. We're creating a new network namespace, but now there's nothing there, right? There's no network devices. And so how do you set up communication? Once you've created this network void of knowledge, right? There are no network cards plugged in. Well, you use the same commands that you would use on your host system to declare that there is a new device or configure it or set its IP address, except you have to create something that's called a virtual network device. And so what I'm doing here is we're adding a virtual Ethernet device And so this virtual Ethernet device has two names. There's the name that I'm creating, and then there's the other end of it. Okay, these are two Ethernet devices that are just plugged into each other. Okay, that's kind of weird. So right here, we've created two of them. Then we add, where is it? Okay. Down here, I'm using the IP command to exec inside the network namespace to add an IP address to a virtual device. And so that's adding one device, plugging it into the network namespace container version. And then on the host side, this is me plugging in a network device that is the other end of that connection. And that allows us to communicate, to build virtual networks, because we create these virtual network namespaces or we create these network namespaces where we can then create these virtual network devices and decide what processes they're plugged into or what namespaces they're plugged into. And this allows you to communicate across network namespaces via these virtual devices. So network namespace is a little bit different. You don't have to know this for the challenges. Most of the challenges I'll play around with the mount namespace. I think if you cruise around there and just focus on the first half of what we did today, you can get there. But I think this is interesting. For whatever reason, I can't run this on the dojo, but it would have been cool if I could. The third demo was going to be something related to pivot root that exploded. So containers themselves, and you can look this up, like Docker's implementation of containers is three things. And you've seen two of these three things. There's namespacing, which is how the kernel lies to you about the world around. There's setcomp. What does setcomp do? Restrict syscalls. Right? And if you look into the way that Docker can be configured, Docker is configured via namespacing, and then there's also setcomp rules. So you can say, hey, I want this to execute, but only be able to do these specific actions in this controlled environment. And the last thing is something called C groups. There should be an S on there. C groups are a way of limiting the amount of resources that a process can use. So I can create a container and say, even though this, or like the Dojo environment does it. If we were to look at, is this in the VM? It is not. Good. LS CPU, we see that there's a bajillion CPUs, right? There's what, 40 of them? This is actually how many CPUs are on the host system. But if I were to, try and solve the race conditions or sandboxing and decide it's all just luck, I need to run as many infinite loops as I can, which some people certainly try that every semester. The Dojo challenge environment is restricted via a C group such that your Dojo environment at most can peg, I believe right now it's still 4 CPUs. So if you spun off 200 threads and you're like, all of them just go, you yourself can burn no more than 4 CPUs. When an entire class decides the answer to everything is to just spawn a bunch of child processes and infinitely loop off. Well, if 10 of you decide that that's the right way forward, that's how the Dojo catches fire, right? Historic. But the point is that Docker and containers, like what we think of as a modern container, is just leveraging these core primitive technologies, namespacing, setcomp, and then C groups or control groups to restrict resources. Now, I didn't have time to pull the link, but a few weeks ago, to make this all kind of relevant, Anthropic, they're the guys behind Claude, right? We all love LLMs now, right? It's the answer to everything. We're all unemployed. Claude recently had, hopefully it's still in their news, they talked about, let's see if I can find their news feed. Where help me? Blog sounds good. They what's that?
Go back.
Wait.
Under the bottom right.
Bottom right.
Down.
Down.
You're there.
News. Okay. They very recently, because it hit Hacker News, we were talking about they had a brand new way, because if you use Claude Code, of trapping Claude Code and stopping it from blowing away your file system, right? You've probably seen the memes of that, right? And they're like, it's okay, we have
Different postcode, stacked overflows, put a random. For LLM, RM.
all right. Beyond permission prompts, I think this was it. There's this great article. They talk about how they're going to stop Claude from blowing away your critical files, right? Because we're all, we don't pay attention to our class anymore. We just fire Claude in a directory. What stops Claude from blowing away files outside of your project folder? Nothing? There could be nothing. Right? You could just set it free.
Nothing in that guy's case.
Yeah.
What's that?
Nothing in the guys whose files is the
Nothing in the poor guy's case who did manage to get it all blown away, right? Instead, Anthropic says, hey, we invented something that's super cool and brand new and novel. We came up with our own new sandboxing technology, right? We're going to throw Claude inside of a sandbox so Claude can't even see your critical files, right? How do you think that works? They aren't ripping off Docker, right? But how do they do file system isolation? Man, it sounds like groundbreaking stuff. I've never seen it before. How are they isolating the network and stopping Claude from communicating with every other laptop and taking over the world? What?
Unshare.
Okay, you say unshare. It's brand new stuff. They have a brand new sandbox runtime, right? And they have lots of documentation on it. What you'll find here is it's built around this thing called bubble wrap. I'd never heard of bubble wrap until this article came out. I was super curious, and it's like, okay, well, what is bubble wrap, right? Is this some new mind-blowing thing?
I see a bindmount.c.
Uh-oh. Well, what do you see? Oh, no. Right? Exactly. You're like, oh my gosh, they come up with something. It's open source. It's brand new. It's how they're controlling the LLMs. This must be something that I've never heard of before. And if you were to dig through here, you will find that they are just using, and just is probably doing them a little bit of disservice, because there is the serious engineering effort in writing something like this, right? With the underlying primitives that they use, anyone want to guess what they are? It's namespacing, set comp, and C groups.
That's crazy.
It's the exact same things that backed Docker containers back when Docker first came out and have been around longer than Docker, because namespacing is a Linux specific way of getting the kernel to lie to you. And so we just set the AI free, and we just make sure that the kernel lies to it so that it can't interact with anything that we don't want it to. And so this idea of sandboxing and namespacing, it can sound real crazy, but it's very relevant. Whether you are trying to run some distributed system on Kubernetes that relies on containers, or just an abstraction of what is my file system and what are these exposed to, like what can they communicate with, that's wrapped up into this nice abstraction that we think of as a container. But every time you start a container, the whole system is just using namespaces, set comp, and C groups. You want to set Claude free and figure things out. Namespaces, set comp, C group. These are super awesome things to understand, and they're very powerful. So, like one of the things that you can do with containers, I can't run Docker inside the dojo, and I don't know that I want to risk it on my home system because I don't know when I'll leave. I'll dox myself. It's a crazy way. But you can run docker-v to mount a volume, right? What do you think that does? Just based on what we've seen here today. What do you think Docker dash, well, maybe you don't know. That's probably not fair. If I Docker help, we can see dash, where is it? Or Docker run help. You can dash V to mount a volume or to mount a file path. What do you think that does? Based on what you've seen today. I want to mount my work directory. All right, we're going to do something. Okay, we'll make dir my cool work dir. All right, I need an Ubuntu environment, and I need to do it in Docker, and I need it to have access to this folder. So what would I do? I would Docker run ti -v. My present will make it a little bit bigger. My cool work directory, and I want that to be mounted inside the host container at, we'll say workdir, and I want it to be in Ubuntu image. We'll say 2404. Okay, it probably helps if you run Docker. Okay, and if I ls workdir, there's my cool file. I'm inside my Docker container. How did it do this? What do you think happened? Was Docker just magic? Yeah? Well, I mean, you can accept that. Like, I would be willing to bet that like 80-90% of devs don't understand how Docker works because you don't need to. You write a Docker file and you're just like, oh man, it's magic, right? But you will be more powerful as a dev, whether you're into security or not, if you understand how these technologies actually work. So, what does it have to be doing if it's going to lie about my file system? It's going to be creating a mount namespace, right? How is it going to, hint, hint, mount my cool workdir as workdir in this host system? Why does this exist? Inside the mount namespace, we've mounted something onto workdir. It created a mount namespace, and it just mounted from the host system back in while it was doing that pivoting crazy nonsense to change what root is. A Docker container or a Docker image is really just a packaged up file system that gets loaded in to your mount namespace. Instead of trying to like pivot to something that is already on your host file system, your file system is abstracted away into this file that we refer to as a Docker image. And so we create a mount namespace, we unpack that file system, and then we mount it into our mount namespace. None of it's magic. Questions, comments, concerns? I got about 5 minutes. I think I did better than I thought for the demo. Nothing? We're just chilling. All right. I dig it. So for the namespace challenges, I know for a little bit it said that you had to run it in a VM. I don't think you need to anymore. An important thing to look at as you're going through these is thinking about exactly what I just showed here, which is when you pivot root, there's a new root, there's an old root. Is proc the proc for the new PID space, or is it from the host PID space? What does that mean? How does mounting something from the host system into the guest, I guess we'll say, or the container file system, what are the implications of that? Can you leak resources that you otherwise wouldn't be able to access? Now, I didn't have time to finish the slides. There was one slide I wanted to make that I thought would have been super cool. Can anyone, just based on what we've talked about, tell me the difference between what's going on here with these containers and a VM?
They don't share the kernel if you're in a VM. If
Okay.
you're in a namespace, you share the kernel.
So the statement was a VM doesn't share the kernel, but a container does, right? Because if I were to draw this, right, if I'm inside, let's not do it in my Mac. If I'm inside the container here, or inside my namespace here, when I ls, what kernel am I communicating with? The host kernel. And when I ls down here, what kernel am I communicating with? The host kernel. In this case, they're both the VM kernel. Now if I go over here and I ls, this is a bit of a trick because the difference on host names is very small. But this is outside of the VM. What kernel is this interacting with? I guess okay, it's all alive. All right. So This is the VM's kernel. This is the VM's kernel. This is the actual host kernel. All right. It's a little bit hard to see, but when you run that VM start command, if you happen to, what that does is that launches this process here, which runs QU system, which is a full virtual machine. How does a virtual machine work? It's very similar to like your Yarn 85, right? What is processing all of those assembly instructions? Right, like an emulator, right? Very, very similar idea here. Now, VMs can do a bit fancier stuff when it comes to acceleration, and they leverage a lot of hardware features where there's magic hardware bits that allow you to execute, as long as it's the same assembly architecture, all near native. But we can think of it very similar to how Yarn 85 works with the emulator, right? All of the assembly instructions of booting up the kernel are running on the VM. All of the assembly instructions of those programs are running on the VM. If you're on a VM, you are paying a big performance cost because all of that has that overhead of that translation in software, and you're running a kernel in userland, essentially, that then has to talk to your real kernel on the host system. But when you are leveraging containers and namespacing, you don't pay any of that. Your communication is almost the exact same as if you were bare metal. It's just that the kernel is going to lie to you. Now, there's a little bit of performance cost. Like I saw, what do you mean? There's got to be something. There is a little bit of performance cost in the fact that the kernel has to do this lookup and be like, all right, what lie do I tell this guy, right? And if you think about the dojo system, right? There's hundreds and hundreds of users that'll run the system at the same time. All of those are in their own namespacing. And every time that you run ls as hacker 1 and somebody over there that's hacker 12, they're getting different lies from the host system, right? And that's totally fine. And so it does scale, and it is reasonably fast. With that, I'm out of time. I think I'll leave you guys there. Let me double check Twitch. Anything good? Mount binds, awesome, setcomp, eBPF. eBPF would be cool, but we're not going to do that one today. All right. With that, I'll leave you. Kernel launches tomorrow. We'll see if anything's broken. If it is, let me know. And yeah, see you next week.